Alright, welcome back, and in this video we're going to be covering how to solve using the quadratic formula. Okay, so in another video I may go ahead and actually prove the quadratic formula using completing the square, but for this video it is assumed that you have seen it a little bit before, but I do want to go over it again, how we can use it to solve any quadratic equation. Okay, so one thing that you definitely need to know is that in order to use a quadratic formula, we need to be in standard form, okay? We absolutely need to be in standard form. So for example, this is not in standard form. I would need to move the 7x over by subtracting 7x from each side to get 4x squared minus 7x minus 2 is equal to 0. And once I get it in standard form, now I can go ahead and use a quadratic formula, okay? Now, you see a lot of A, B, and C. Remember, those are just the coefficients and constants in this problem. A is our leading coefficient, in this case 4. B is our linear coefficient, in this case -7. And C is our constant, in this case -2. So, to solve this using a quadratic formula, we just go ahead and follow it. So the quadratic formula is x equals opposite B. So in this case, it'll be positive 7 plus or minus the square root of b squared, so -7 squared, minus 4ac, and the whole thing is over 2a. So see, I'm just plugging in the values. B squared minus 4ac minus 4ac all over 2a, okay? And now what we do is we just start simplifying this, okay? So we're going to work on the inside of the radical, so we're going to have 7 plus or minus the square root. -7 squared is 49 minus 4ac, well, -4 times 4 is -16 times -2 becomes a positive 32, so that actually becomes plus 32 all over 2 times a, which is 4, so 2 times 4 gets us 8. And now we keep simplifying, so this is going to be x is equal to 7 plus or minus the square root. 49 plus 32 is 81 all over 8. And then from here we can simplify. If you can simplify, make sure you always simplify. So we can actually take the square root of 81. The square root of 81 is 9. So this becomes x equals 7 plus or minus 9 over 8. Okay, and we can actually go ahead and figure out what those numbers are. 7 plus 9 is 16, and 16 over 8 is 2. So that's going to be one of our answers. And 7 minus 9 is -2, and -2 over 8 is -1/4. So that would end up being our final answer, okay? So that's how we can solve using the quadratic formula. All right, I do want to take a look at just another couple problems just to make sure that we're really on it. So let's go ahead. I'll see if I can squeeze it in here a little bit. Let's take a look at a problem. Let's try 7x squared plus 6x minus 4 is equal to -x squared. Well, once again, we need to be in standard form. So I need to move this x squared over. So I have to add x squared to each side, and this is going to become 8x squared plus 6x minus 4 is equal to 0. And you can go straight to the quadratic formula here, but I always advise to look for a greatest common factor. And in this case, we have a greatest common factor of 2. So me personally, I would actually divide each side by 2. You don't need to do this, but it would help us out a little bit. We can divide each side by 2 to get 4x squared. Plus, that would be 3x minus 2 is equal to 0. And the reason I would recommend doing this is because now our numbers are going to be a little bit smaller, which make them more manageable. Okay, and now in this case, a is 4, b is 3, and c is -2. So now I just plug it in. So now x is equal to opposite b, so that would be -3 plus or minus the square root of b squared minus 4ac all over 2a. So we see I'm just plugging in b, a, and c. That's all I'm doing. So now I continue and I simplify. So this will be negative 3 plus or minus the square root. 9 is 3 squared. Negative 4 times 4 is negative 16. Times negative 2 is a positive 32. So that becomes 9 plus 32 over 8. And now I got to keep simplifying. This is going to become x equals negative 3 plus or minus the square root of 41 over 8. And we got to see if we can simplify the square root of 41, and we can't. So that's actually going to be our final answer, okay? So if you take a look, in this case, our answers were irrational. And in this particular case, the solutions were rational, okay? Rational just means it could be written as a nice fraction like 1/2 or 3/5 or 2 or 18, okay? Those are rational numbers. Irrationals are numbers that cannot be written as a nice simplified fraction, some crazy decimal that continues with absolutely no pattern, and that's an example like this. If you have a square root that's not like the square root of 9 that you can simplify, that's a dead giveaway. It's going to be irrational, okay? And irrational numbers are something like pi and e, and that's also irrational, okay? So I'm going to take a look at why this is rational, why this is irrational in the next video, okay? But I just want to point it out to you now. But I want to take a look at just one more example. So just one more example. So let's go ahead and scroll over here, get some new room, and let's try out a new problem. How about we have 7x squared plus 2x plus 1 is equal to 0. Remember, first step is to make sure that we're in standard form, and in this case, we actually are. This is the first one that we actually have in a standard form. So we can go straight to using the quadratic formula. And in this case, a is 7, b is 2, and c is 1. So when I plug this in, I'm going to have opposite b, so negative 2 plus or minus the square root of b squared, so 2 squared minus 4ac, so that's 4 times 7 times 1, all over 2a, which is 7. And now we go ahead and we simplify. So we simplify until we really can't anymore, so this would be negative 2 plus or minus the square root of 4. Negative 4 times 7 is negative 28 times 1 is still negative 28, so that becomes 4 minus 28 over 14. And from here we can simplify this a little bit. So this is negative 2 plus or minus the square root of negative 24 over 14. And once again, whenever we have a negative underneath the square root, that means we're going to have imaginary solutions. So we pull out an I. So that's negative 2 plus or minus I root 24 over 14. And if you can simplify the square root of 24, make sure that you do so. The square root of 24 can be simplified because that's the same as the square root of 4 times 6. And we can take the square root of 4 to get 2 root 6. So what this is going to become, and let me go ahead and put it up here, this is going to become negative 2 plus or minus, I can simplify the square root of 24. That's 2 root 6, so that'll be 2i root 6 all over 14. And we can actually simplify this even further. If for any reason you get a solution such as this, and each of these three numbers, let me go ahead and circle them, each of these three numbers have a common factor, you can divide the entire problem through by that common factor, okay? So in this particular case, we can divide each of those numbers through by 2. Note, I'm not talking about what's inside a square root. We do not touch that. But if the number that's in front of the square root or this constant or that constant are all divisible by a common number, we go ahead and we can simplify by dividing each of those common numbers. So we can divide all of those by 2. So this would become negative 1 plus or minus 1i root 6 over 7. So I divided each of those by 2 because we can, and that would get us our final answer. And just notice that in this particular problem, we had answers that were complex conjugates of one another, okay? So we had rational solutions, irrational solutions, and complex conjugate solutions. And in the next video, we're going to talk about how we can tell what types of solutions we are going to have, okay? So that's solving using the quadratic formula. Make sure you stay tuned for the next video to find out how we can use what we call the discriminant. You'll find out what that is in the next video to determine how many and what types of solutions we will have from a quadratic equation. So make sure we're practicing and stay tuned for the next